Isaac Newton, very famous mathematician who came up with the idea of forces, gravity, and how do you derive these equations. I will not be discussing that today, but I will be discussing how he derived equations for gravity, or how he derived orbit. Now, you probably already know this. A lot of people who don't, this is how it happened. Say you have a stick, you have the curvature of the Earth. You're going to accelerate the stick up in the air. The stick will accelerate, but it will go into a curved pattern because of the curvature of the Earth. And if you accelerate it enough, it will continue missing from falling. And it will just continue missing and missing and missing. And if you were that object, you would feel kind of weightless because you keep missing. Now, if a more relativistic image of gravity is correct, then orbit is caused by the geodesics, which is derived from Einstein's field equations, which basically is 8 pi g over c to the 4 times the stress energy tensor, which is basically momentum, energy, and mass, is equal to the cosmological constant, the Ricci curvature tensor. Alright, so 1/2 the Schwarzschild radius, and some more tensors. Tensors are basically multi-dimensional arrays of numbers that, in physics, account for physical processes. Like, I could use a thermodynamical tensor to figure out exactly how the heat is being exchanged from this object when I hit it to something, or the energy, or momentum, or force, or anything. Tensors are very useful. Very useful in finding different physical processes. But let me show you something. Say I'm gonna go right here, and I'm going to have to show you a little experiment. So say if I take this right here and I bring it back, right, and I just let go of it, that right there is not really that extraordinary, because it's just like, oh, it's just gravitational potential energy being converted into kinetic. But what is strange about this is that it never fully goes back into kinetic because of these tensions, because of tension force by these ropes and then the metal chains. So when you put tension force and the gravitational kinetic energy, or potential energy turning into kinetic, and plus the kinetic energy I am applying into the system, and kinetic energy is basically moving energy, which energy is the total amount of work a system can possibly do. And work is force over distance, or change in kinetic energy. See, so look at that. So say I had stopped this thing by applying enough force to go against all other forces acting on it, and I bring this thing back. If I let go, it's going to keep going and keep oscillating back and forth. Now the reason for doing this is because of tension, like I just said. But the oscillations are also decelerating because of the more gravitational effect on the object, and also the tension slowing it down. Also the friction between this, which also creates more force on the object. And also air resistance. Air resistance is basically a force applied by the air. Not very hard to explain. I'm going to show you something else. Light switch. I think, oh, that's not too extraordinary. Well, we can map out the exact electromagnetic wave distribution from different electrodynamical equations. I will show you one equation that can be easily used for this. But this is only about separate fields. So let's say the electromagnetic field strength is equal to the force over charge. So you have a point charge and then a big charge. Not huge amounts of implications. Then you have Coulomb's law. If I just do this, not that complicated really. You have Q1, then it's just Q2. Not very complicated whatsoever. Now let's show you a just 1 second. There's this equation that has that's of relativistic mechanics that I'm also going to show you. That is the total energy equation, relativistic energy equation. Basically, as energy is equal to mc squared, all squared, plus pc, all squared. This is only in frames where the object is actually moving. It will just go away. You can just cancel this out, and then cancel the squared term out, and then it just be E equals MC squared. Which basically just tells you the total rest mass energy of a object, or increase when it moves. Amplifications for this are obviously nuclear physics, but we'll get more into that later. Now, hopefully you guys actually enjoyed this video. Hopefully you'd like to see more about peoples.